Hello and welcome to the next tutorial. Today we are going to look at the PLC project, and I'm going to show you the basic structure here as well, like we already did for the HMI. Let's just take a look where we can find the ProProg project. In the ProMaster default project directory, we have our motion access web and foil directory. In there we go to IEC template. And there you can find the ZWT file, which you can just open by double click. And it will ask you if you want to unzip it in the same folder, in the same directory. We just select yes. And the next messages will just appear if it detects the same library on your system and if you want to override it. So you can take a look at that and maybe the version changed, and just be careful with that. But in most of the cases you can just replace it. That's not a problem. Or you can just select do not extract because I already have it. And yeah, so let's just skip that for all of the libraries. That will take a while. So there we have the project unzipped, and let's take a look at what we have here. First of all, we have the libraries section where you can find all the function libraries included. These yellow ones, yellow looking libraries here, or books, let's say, are just firmware libraries, and the blue ones are the user libraries. The firmware libraries, they just offer firmware close functionalities. For example, reading, writing files, talking to the PLC system, getting information out of the PLC system. And the user libraries, they are, let's say, on top of the firmware libraries, and they can be used for anything because they sometimes also need or use the firmware libraries. So for example, let's say we have the recipe functionality, which is using, of course, some file reading and write functions, what is part of the system or firmware library. What is important here? So let's go into the motion control library. So we have motion control functionalities like move absolute, move relative, power on, read status, move superimposed, and this is for ECM, is for EtherCAT master functionalities. So you can control the EtherCAT master, you can read and write service data and stuff like that. The next important one is EtherCAT diagnosis, which, like the name says, is for EtherCAT diagnosis, so you can get information out of the EtherCAT system. EtherCAT var handle is for if you have optional slaves, let's say, or you have several slaves in your system that you want to be not mandatory. With that function block, it is allowed to handle, to manage slaves in your system and shuffle them around and stuff like that. Tag tools is a library which contains a lot of function blocks regarding drive, reading errors, state monitors, just, let's say, little helpers that enable you to handle stuff more easy. So you can use that, of course, as well. TP measure is for touch probe. Yeah, like the name says, you can control touch probe functionalities in there and measure the touch probes, the positions that come with the measurement, with the position. Then we have the cam switch, which enables you to switch digital cams depending on conditions like positions. If a position is reached, you can switch them on in a specific area. You can switch it on for a specific time when the position is reached and stuff like that. A take recipe is for recipe handling, and OSCART Basic is just a freeware library available to the system, which has a lot of tools and functions, little small functions. Some of them are a little bit more complicated, but it's an open source library. Then we have the data types, where we have the interface types. That is for the communication to the HMI. We have retain types, which is for retain data in the template, for handling the retain data. and the user types, which is for handling the control blocks or the function blocks in the template. I will show you later more about that. And the logical POUs. POU stands for Programmable Logical Unit. And here we have the function block instances. Let me just uncollapse this. And we have the function block instances where we have all the function blocks instantiated for the template, like file handling, motion control function blocks, as you can see here, and system function blocks like MC control, call Windows app, which enables you to execute an application on the Windows side, technology function blocks. Here we have the HMI POUs, which is for handling the HMI data, so data that comes from the HMI and that goes out to the HMI. Here we have a POU which is doing the retain data handling, and the state machines. So we have state machines for recipe handling, because we have to do a little bit of logic behind the scenes, let's say, in order to store recipes, to load recipes, to rename them, and stuff like that. Then we have the template state machine, which is the main state machine for our template, and where all the magic happens, like homing, powering on, jogging, camming, gearing. And this POU is for getting information about the load that the system has to deal with at the moment. So here you can see whether the event cycle is running, how big the load of the event cycle is, and this is just a POU which is basically empty, where you can just test stuff. Then we have hardware configuration here, which contains a coding guide, which tells you more or less how the template is coded, in which way, and I suggest keeping that coding guide throughout coding the template. So if you want to extend it with your functionalities, try to keep up to the coding guide as much as possible, because in that way we can also support you better if you have problems or questions, and so we can read it more easily, let's say. We have a change log, where you can write down the changes you made to the template and create a new version. And we have the task configuration here, which contains all the event and cyclic tasks, and the global variable list.